everyone, welcome back to another episode of Cyber and You, where we're empowering people through knowledge and entertainment. I'm your host Taylor, and today we're here to talk all about Linux file permissions. So I just want to take this time to say thank you for the feedback that we've been getting on the videos. One topic that I failed to discuss last time was the difference between directories, files, links, things like that, and how you can determine that with the ls command. So like I say, with every single Linux video we're going to find out what directory we're in with the pwd or present working directory command. So as you can see, we're in documents. So let's just go ahead and do a long listing of this directory. So I want to just go ahead and highlight the difference right here on this mode string. So the mode string is really what we're going to cover today in this video. So this part right here, this is what we call the mode string. So that first character, as you can see here, we have a hyphen. So that's going to tell you that it's an ordinary file. Here with the D, that stands for directory. And here, this is a link, whether that be a hard link or a symbolic link. We'll go into further detail on what those are in later videos. So with that said, we'll just jump right into the permission sets. Alright, so now that we have this long listing up, I'm going to go over the mode string a little bit in further detail for you. So as I said earlier when we were going over the different types of files, directories, and things like that. So what we're focusing on in this video is right here, this little mode string. So it's going to tell you a little bit more. So I actually created a file here in the documents. It's going to give us a quick rundown of what those are. So to open up the contents of this file, we're just going to type cat and the name of the file. So I was showing you the mode string for some of these various files up here. So I just broke it down a little bit more in this permissions quick reference. So as you can see, R stands for read, and that gets a numeric value of 4. Write is W, gets a numeric value of 2, and execute, which is X, it gets a numeric value of 1. So I broke down what other combinations of these numeric values are. So read, write, execute is 7, read, write is 6, read and execute gets a numeric value of 5, read is simply 4, write and execute is 3, write is 2, execute is 1, and then obviously when you have a null value, it's 0. So some common things that you might see, you have 777, 754, 654, any type of this is actually what this represents. So these numeric values represent these permission sets. Now, directories and files differ in their actual maximum values. Directories use a 77 mode string while files only use 666. And this is useful in determining the Umass, which we'll cover later in this video. Alright, so the next thing that I want to cover in this video is to further break down the mode string and what it actually means. So let's take this first file of Cyber and You. So we've already determined what the first character is. That determines that it's a file. So let's go ahead and start here. These first three values of the read, write, and the null execute value. So what this means is that the owner of this file, which would be Taylor, would be able to read and write from this file. Now, let's go to the next three. Same permission sets, but it means a whole different thing. The group, people in the group Taylor would actually be able to read and write to this file as well. Now the last three here, they would only be able to read. So that's all other users. All other users would be able to read Cyber and You, but they would not be able to write to it or to execute it if it was an executable file. Let's jump down to this directory. So same thing, these first three. So Taylor, people, the owner, which is Taylor, would actually be able to read, write, and execute to this directory. So it's a little bit different. Writing to the directory would be able to create files within the directory, make other directories within the directory. Execute would be able to open up files within this directory and read, be able to actually read the contents of the directory. Same thing for read, write, execute for the Taylor group, and For this, you'd be able to, for all other users would actually be able to read the contents of the directory, and they'd be able to execute any executable files within this directory. And because they don't have write access, they would not be able to create other directories or files within that directory. So now that we've covered that, I want to go over the Umass value and actually how that goes into creating default permissions for your files and directories. Alright, so I want to go over the Umass command and actually what it does. So Umass is going to tell you how, when you create files and directories, what the default permission set is going to be. So let me go ahead and show you what that means. We'll type in Umass here, and as you can see, that says 002. So what that means is that when you create files and directories, it's automatically going to subtract a numeric value of 2, which, if you remember what we were talking about back in the permissions quick reference, is that that's going to take the write bit away from all other users. So let's just go ahead and create a file. So touch file 1, do ls-tac-l, and as you can see, for file 1, indeed it did take away the write permission from all other users. Now, as I was saying earlier, the default maximum value for a file is 666. So what that means is that if you created a file without a Umass value, it would actually create a read-write permission set for the owner, the group, and all other users. But because the Umass value subtracts 2 from the permission set, it's going to create it with a value of just read for all other users. Now, if you want to change that permission or default permission set, you just type Umass and you change it to whatever you want it to be. So here we're going to remove the write permission set from the group as well. So let's just go ahead and do that. Touch file 2. Let's do ls-tac-l, and as you can see, it actually removed the write permission set from the group as well. So let's just do a quick comparison between the two files that we created. So you can see read-write for the owner, read-write for the group for file 1, but only read for the group in file 2. And as you can see, there's no difference between the two for the all others group. Alright, and the last thing I want to cover in this video is the chmod command and how you can use it to modify permissions for your files. So we're in the documents directly. Let's just go ahead and do a long listing real quick. And as you can see the permissions here. We're going to work on the CyberNU file. So as it stands right now, you have permission set of 770, means that it has read, write, execute for both the owner and the groups. But what happens if you just want to lock down this permission set for the group and just make it read, write, and execute for the owner? So let's just go ahead and do chmod. We'll use numeric values right now. So to make no change to the owner, we'll just do 7. Now to revoke access to the group, we're going to use a 0, 0, and we'll use CyberNU. Now let's go ahead and do a long listing here, and as you can see, there is a difference here. We actually removed the read, write, execute on the group. Now, say something comes up and you actually want to restore that access to the group. We'll go ahead and do chmod. Now this time I'm going to use the actual alpha symbols for it. So actually we're not going to do anything with the owner, but if we were, it would be owner. And let's just go ahead and say plus read, write, execute. It's not going to make any modifications, but I'm just trying to show you what would happen. Do a comma, group. Let's do read and execute permissions. And for others, we're just going to subtract read, write, execute. I'll do it for the CyberNU file. Let's do ls-tac-l again. And as you can see for Cyber and U, read, write, execute for the owner, read and execute for the group, and no permissions for others. And that's how you use the chmod command on both alpha and numeric values. In a later video, I'll cover more advanced permission sets like set UIDs and sticky bits. But for right now, that's all we have for this video. If you liked what you saw, just go ahead and subscribe. Don't forget to follow us on Twitter at CyberandU1. And if you have any feedback, please leave your comments below. Thank you.